So I'm inside the listdemo.java class, and you'll notice it's implemented, but everything is commented out for now. And we'll uncomment bits and pieces of this as we go. I want to use the first part of this as a reminder of like what we did last week in terms of implementing a linked list. So I'm going to highlight these lines here, 8 to 12. And if you hit like Windows slash or what is it on the Mac, Alt slash, I think on the Mac, um, it will uncomment all the lines of code at once, which is super convenient. Um, and so now we have some code here that makes a new linked list. To be clear, this is our linked list, not the Java standard library one. What key did I hit? Win, or is it control? Sorry, control slash. There we go. Um, so this is our linked list, and we're adding some nodes. But what I thought would be helpful here is if I set a breakpoint on line 8 and then click debug. Let me step over creating a new linked list. We can remind ourselves of like what a linked list is. So the variable staff refers to our linked list. First has a value of null because an empty linked list has no elements, has no nodes. And so we capture that by having first equal to null. First refers to the first node in the linked list. So when we add Tom, if I step over that line of code, we'll see that first now refers to a linked list node. The syntax here is a little weird because node is a inner class inside of the linked list class. That's why it shows up as linked list $node. So that's odd, but I can open that up and I can see that the node has two instance variables, data, which is the string Tom, and next, which has a current value of null. So the last node in our linked list will have its next instance variable be null. There is no next node because this is the last node. In fact, right now, this is the first and the last node. But if I step over the next line of code, line 10, when we're adding Romeo, so let me do that, we can now see, and to be clear, I'm calling add first here. So now the first instance variable refers to a node that contains the data Romeo. And next, if I open this up, next refers to the second node in the list, which has the data Tom, and its next is null. So by using the debugger, it can help us visualize a little bit here how these nodes are linked together. So when I add Harry as the first node, and I scroll back up here, here's the staff references our linked list. First refers to the node whose data is Harry. Next refers to the node whose data is Romeo. Next refers to the node whose data is Tom. And finally, one more step here for Diana, and we can now see all the nodes linked together with their associated data. Node with Diana, node with Harry, node with Romeo, node with Tom, and then next is null. So I think in this chapter, especially, sometimes stepping through the debugger and opening, twisting all these little carrots so we can better see how the data is organized helps us build like our conceptual understanding and visual model for like what is a linked list and how is it represented. So that's kind of our review of what our linked list thing looks like. What we're going to do today is we're going to focus on the list iterator class. So I'm going to close this, and I'm going to go back to linked list.java, which is where we left off the other day. And we're going to, where did we leave off? Let's see, right here. So we had implemented already, we implemented the constructor, get first, remove first, add first, and here is where we're going to implement the method to return a linked list iterator. We're going to make this look just like it does for the Java standard library. So this will be a public method. It's going to return a list iterator. And we're simply going to say return new linked list iterator, which we haven't implemented yet, but we're about to. So it's not happy with us yet, but it will be. So this method behaves exactly like it behaves in the Java standard library linked list that we used last chapter. We will invoke the list iterator method on our linked list to get a reference to an iterator, which we can then use to do more sophisticated operations with our linked list. Add first, remove first is fine, but it's pretty limited. So having this list iterator will let us do many more things. So here is our inner class for the node, which we had previously written. Here is going to be our class that we're going to implement now. So we're going to uncomment this implements list iterator part, because list iterator here is an interface that I've already written for us, just in the interest of time. So list iterator is like the Java standard libraries list iterator, but with fewer methods, because like our intention is a little bit more focused. So list iterator is an interface. There is a next method. There's a has next method. There's an add method, a remove method, and a set method. So you can see like it's a subset of the normal list iterator methods. There's nothing about previous or has previous, because again, we're focused on a singly linked list, but we will implement these 5 methods. So next, has next, add, remove, set. So going back to linklist.java, I can now uncomment this, and then we're going to work our way through implementing our linked list iterator class. So this is a little tricky, and so hopefully between a combination of the code we're going to write and some of the pictures we're going to look at, it's gonna make sense as we go. But we'll take it kind of like step by step. We're going to start with the instance variables for a list iterator and then build on that. So we're going to type them in first, and then we're going to explore like what they really mean. So we need 3. A linked list iterator needs a reference to a node, which is its current position. For reasons that will become clear, it also needs a reference to a different node, which is the previous node it was at. It's not enough to know where we are. We need to know where we were before. Why that is will become clear shortly. And then we also need another instance variable to track the state. We need to know if the next method has been called. So I'm going to call this instance variable is after next. So if the next method has been called and other methods haven't been called, we'll set that to true, and we'll check if this is true before we do certain operations that require next to be called. So like remove. So those are our 3 instance variables that we are going to focus on throughout this code. So let's implement the constructor, and then we're going to look at a picture. I think that's the best approach. So here's the Java doc header for the constructor. Construction iterator that points to the front of the linked list. How do we choose to do that? Well, we have our constructor public linked list iterator, and then we are going to initialize our instance variables. We're going to say position equals null. Oops. position equals null, previous equals null, and is after next equals false. Let's dive in a little bit about what we mean by position and previous. So in chapter 15, I encouraged you to have a conceptual model of a linked list iterator where we thought of the iterator as like pointing between nodes. And I think conceptually that was really helpful because then when we added a node, it was very clear where it would go. It went between the two nodes if the iterator was pointing between the two nodes. That's a great conceptual model. And I think that was a good place to start for chapter 15. I hope you agree. But like a variable can't point between two things. Like that doesn't, once we have to code this, that's not a thing anymore, right? We need to actually refer to a node. And so we can't have an iterator point between nodes. We need an iterator to refer to a single node. So what I mean by this, and we'll look at the picture here. Here is an example of a linked list, okay? Not unlike the one we just ran to kind of review what the nodes look like. So when we create a new list iterator, these things are set. Previous is set to null, position is set to null, is after next is set to false. We're about to implement the next method. And when we do implement the next method, so this iterator, going back a step, when position is null, it means the iterator is at the very beginning of the list. So when we invoke next, it should iterate over this node here, the first node in the list, the node referenced by the first instance variable in our linked list object. It should return the data of that node, which in this case is Diana. And the way we keep track of our position is position will equal, it will be a reference to this first node. So position refers to the node that we have just iterated over. It refers to the node whose data we just returned by calling next. Okay. Is that more complicated than our model in chapter 15? Yeah, for sure. But we have to refer to it in a node. We can't like refer between nodes anymore. So when position refers to a given node, it is pointing at the node that we just iterated over, okay? So we need to keep that in mind as we go. So let's try this out with some code. And we're just gonna take it today like just one step at a time as we go. All right, so let's implement the next method. So we're going to say public object. Again, nothing here is a generic. Just to keep things a little bit simple for now, our type of all of our data is just of type object. So the next method we're going to implement first. So how's this work? So we're going to build up this method incrementally. We're going to start with the simple case of being at the beginning of the list. So we're going to say if position is equal to null, which it would be when we've just created a new iterator that's at the start of the list, we're then going to set position equal to first because we're iterating over that first node. And then we're going to return position.data, right? So next doesn't return a reference to the node, it returns a reference to the node's data. So that's a little bit different. What is a potential problem with this code? We should add a check for what condition? What could go wrong? Yeah, position's null. Yeah. If position is null, this is going to crash right here with the null pointer exception. If position is null, then the list is there is no next node, right? So let's check for that error condition up at the top here. We're going to say if in a moment we're going to implement has next. So let's use that. If has next equals false, if there is no next node, we're going to throw, like we were doing the other day, a new no such element exception. Okay, same behavior as the Java standard library linked list iterator. If we try to call next and there is no next node, we throw a no such element exception. So the code we've written so far handles the case of invoking next when our linked list iterator is at the very beginning of the linked list. So going back to the picture, our list iterator, null, null, false, right? We just made a brand new one. We invoke next. Position refers to this node. Previous is still null is after next is true. Oh, we should update that. We didn't do that part. We just called next and we didn't update the variable. Let's go back and do that. Got to keep track of our state. So up here, we'll just say is after next equals true because we're calling next. So we'll set that to true. One thing I'm going to mention here, in APCSA, we're always very careful when we're referring to instance variables to do like this dot, right? Like this dot first. I'm less careful in software engineering, but I also wanted but I could certainly say this dot first. Actually, just kidding. That won't work. And I don't think this will work either. I guess it works here. Okay. So this becomes a little tricky once we start having inner classes because what this refers to might not always be clear. But since we're inside of the linked list iterator class, this is going to refer to that object and not the linked list class. So I can't say this dot first. But if you leave out the this, Java's going to figure it out. Okay, so it knows that position is an instance variable of the linked list iterator class, and it knows that first is an instance variable of the containing class, the linked list class. So, but I did want to just be a little upfront and explain like why I'm not doing a bunch of stuff with this like I normally would. I think that's helpful, but when we start nesting our classes, I think it gets a little confusing. So, all right. So we did the is after next. Let's look at the picture. All right. What if we were to call next again? Okay. So right now, position refers to this node. If I call next, it should iterate over this node and it should return a value of Harry. So again, we want position to refer to the node we've just iterated over. So if I call next again, we can now see that position refers to the second node in our linked list, whose data is Harry. So I need to return the value Harry. We can also see that previous refers to the previous node in the list, the one we were just at. So to support calling next in this more general case, when we're not iterating over the first node in the list, you can see we have to update previous to refer to this node. Now, if I go back one picture to where we're starting, the initial value of position is to the first node in the list. So before I change the value of position, I need to first update the value of previous, and then I can change the value of position. Again, the order in which we do things is really, really critical. So first things first, we're going to add a line of code here to say previous equals position. We want to update the value of previous to refer to the current position because we're about to change the position. This if statement handled the boundary case of we were at the very beginning of the list. We need to add an else block for the generic condition of we're just iterating through the list. And we can say position equals position dot next. So previous, we update its reference by setting it to position. Position could be null if we're at the beginning of the list, and we'll set previous to null, but that's fine. If position is not null, position will equal position dot next. Regardless, we always return position dot data. So this is the full implementation of the next method. We're handling the case of there is no next node. We're handling the case of we're at the very beginning of the linked list. And we're handling the case of the generic case of we're just iterating through the list. But in all cases, we return the data of the node we just iterated over. Whew, that's next. So we called has next, so we should probably implement it. So let's do that in the next method here. Test if there is an element after the iterator position, returns true if there is an element after the iterator position. So public Boolean has next. We have to, what would we check to determine if there is a next node? So right now our position refers to this node, the second node in the list. There is a next node in our linked list. How do we know that? Yeah, because position dot next, this reference here, isn't null. It refers to this node. Eventually, this will be null, as we saw when we were stepping through code at the beginning. So we can just return and say return position dot next is not equal to null. As we're implementing these data structures throughout this chapter, the mindset you need to have is to be one of constantly looking for potential exceptions that will be thrown. So what could go wrong with this code? What would cause an exception here? If position is null. So basically every time you see something dot something, you need to ask yourself, could the variable be null? And if so, I need to write some code to handle that because we don't want to be throwing null pointer exceptions. Position could certainly be null. When we create a new linked list iterator, we initialize position to be null because we're at the start of the list. So we have to check that. We have to say if position is null, which it will be when we are at the start of the list. That doesn't mean we return false necessarily. We have to instead look at the instance variable first and return first is not equal to null. If first is null, there are no nodes in the list, and so has next should return false. But if first is not null and position is null, yeah, there's a next node. It's going to be the first node in the list. We should return true. Very cool. All right, let's look at some of the tricky stuff. Let's look at a picture for add first. And so to be transparent here, a few years ago, when we were live coding this in class, I got so confused about how to implement these methods in the list iterator that we spent all class writing it wrong, only to realize at the end of the class, nothing was correct. It was all messed up. And so we threw out all the code the next day and started again. And I felt really bad because like I must have just confused those poor students so much. So this is tricky stuff. Like, so that's why I kind of want to go in small steps and rely on these diagrams a lot so that we understand what these different variables mean and how they're connected to each other. So we're going to do a couple different cases for adding. We're going to start with this one here, where our list iterator, it's a newly initialized list iterator. So previous and position are both null, meaning the iterator is right at the start of the list. We're going to make a new node. Well, we're going to add the string Juliet, which means we have to make a new node and initialize its data to Juliet. And we're going to have a variable called new node that will refer to this new node. So let's just do that step first. Again, small steps, one step at a time. So first things first, public void add takes one parameter of type object. Again, we're not dealing with generics yet. We're going to refer to the value that's being added to the linked list as element. This adds an element before the iterator position and moves the iterator past the inserted element. Okay. So in the picture I just showed you, the iterator position was null. So we're at the very beginning of the list. So this will add the element to the start of the list, and then we'll move the iterator past it. So, so the special case we're doing right now is if position equals null, which it is for the boundary condition we're doing right now, position, we can write code to insert this element at the start of the linked list. But we already did that. We did that last week. We wrote a method called add first that has these three steps where we make a new node, we initialize the new node's data to the specified element, we link it to whichever node was first, or if there's none, it'd be null, which is fine. And then we update the linked list to refer to the new node as the first node. So we don't need to duplicate this code. We can instead just invoke the add first method. Okay. Save us typing, save us bugs, makes this more maintainable. So we're just going to invoke add first. In addition, though, we need to update our iterator. We need to say position equals first because it moves the iterator past the inserted element. Let's look at the picture. Here we are. Now, you can probably tell that I drew the lines by hand, but hopefully you can follow them. So this is what it looks like after the case, okay? Linked list refers now to this node because we added it at the beginning of the linked list. This node that contains the data Juliet, its next reference refers back to this node here, the one whose data is Diana. Okay. We updated position to refer to the node whose data is Juliet because we have iterated over that node by adding it. If we were to call next at this point, we would want to return the data Diana. Okay. So this is what our linked list looks like at the moment. Let's look at a different case. Now, let's say hypothetically, our iterator's position refers to this node here, just a node in the middle of our linked list. This node's data is Harry. We want to add Juliet here. And so we'll make a new node, initialize data to Juliet, and then we need to insert this node into our linked list. When position refers to Harry, that means we've just iterated over Harry. So based on that, the question I have for you is we've got two options of where this could go. So I want you to think about this on your own for like 30 seconds and then share with a neighbor and see if you all agree. Will this new node, whose data is Juliet, be inserted between the nodes for Diana and Harry or between the nodes for Harry and Romeo? Think about it on your own for 30 seconds and then turn to your neighbor and see what they think. All right. It's okay to talk. Talk with your neighbor, see what they think. All right. Who thinks the node for Juliet will be inserted between Diana and Harry? Show of hands. Which pairs came up with that one? And between Harry and Romeo. And some uncertainty, which is okay. This is tricky stuff. This is where it's harder than it was in chapter 15. In chapter 15, it was easy because the iterator pointed between nodes conceptually, so we knew exactly where it was going to go. Here, position refers to the node we've already gone over. Okay, so if this is the state of our list in iterator, we've already called next, and that next has returned Harry. So back in the chapter 15 world, our iterator is here between Harry and Romeo. That's where the new node is going to go. So position always refers to the node we've already iterated over. And so when we call add, it goes after the node that position refers to. Okay, that's definitely a tricky part of all of this. All right, so here's what it should look like after the fact. And you'll notice here it's numbered. There's 4 steps we have to do, and we're going to code each of these in turn. What you'll notice is that we have to initialize the new nodes next to refer to the node whose data is Romeo. Where does that come from? It comes from position.next. So again, back here, position.next refers to the node with Romeo. That's where that comes from. Step 2, we change this node, the one whose data is Harry, to refer to our new node. How do we do that? Position.next equals new node. Step 3, we need to update our list iterator. So position refers to new node. That's pretty straightforward. Position equals new node. And step 4, we need to update is after next to be false. Okay, because we've just added a node, meaning we no longer had just called next. So let's do all 4 of those steps. So we're going to write this inside of an else block. All right, first things first, we need to make a new node. Node, new node equals new node. We need to initialize data to be the element that's specified. All right, I guess that's like step 0. Step 1 is to link new node to the next node in the list. So new node.next equals position.next. And I'm going to add comments here so that you can look at this code and look at the diagram side by side and piece together exactly what we're doing. That's step 1. Step 2, position.next equals new node. Step number 2. that we've now like maintained the integrity of the links within our linked list. Step 3 is focused on our iterator. Position equals new node. That's step number 3. And step number 4 applies in both cases. So I'm going to put it outside of the else block. Is after next equals false. That is step number 4. Yes. Like, how do we do that, or why do we do that? Or so let's look at the picture again. So each node in our linked list has to refer to like the next node in the linked list, right? So we go from the first node, next, second node. Since we're adding this node in between these two, next has to refer to this node here. The reference is stored in the variable new node. And then this node has to go to here. So we're inserting this node between these two. So we have to like fix up our next references so the chain of nodes continues. However, we also need to make sure we update our list iterator, because the behavior of add is when we add the node, the iterator is positioned conceptually after that node. So therefore, position has to refer to new node as well. And we almost always will have position's got to refer to one of those nodes, right? And the previous node in the list will also refer to the node. So it's position and sum next will always refer to the same node, because the iterator needs to know where it's at, and we have to have the integrity of our linked list. All right, so we're gonna pause here, and here's what I highly recommend you do. This code right here is like 6 lines. We wrote like 6 lines of code for like 4 little steps. 5 if you count making the node. The amount of code is not what makes this hard. What makes this hard is all of the references referenced from other references like new node.next, position.next, and the order in which we do these. If we were to do these in a different order, it would all fall apart. Okay. So what I highly recommend you do is you go back later today and you read through the code we wrote for next, adds next, and add. And while you read through the code, you look at the picture and you try to reconcile the code in the picture again, and study it so that it makes sense. And then tomorrow we'll come back and we'll implement the remove method, which is, I would say, the most challenging one that we've got. So good point to break today.